Hello, my name is Meg Baber, and this is Statistics 323. So today we're going to be looking at a completely randomized design with a one-way treatment structure. So the data that we are going to be using is from my mini project 1, where I looked at 3 different types of paper and their effect of the distance traveled by a paper airplane. So our explanatory variable is the paper. And we have cardstock, printer paper, and lined paper. And you can see that I have a first, a second, and a third attempt. And that was because I was trying to minimize or account for the variation in the individual paper airplanes. And so because of that, our response variable is actually the average distance traveled. And so that is measured in inches. So this is a, like I said already, one-way treatment structure at 3 levels. So our null hypothesis that we're going to be testing today is that cardstock paper does not affect flight distance of a paper airplane differently than lined or printer paper. So our alternate hypothesis is, of course, that the cardstock paper does affect flight distance differently. To test this, we're going to be looking at a contrast. So a contrast is a linear combination of population means. It is a difference in 2 means, so we're going to be looking at the difference in the means of the average distance traveled. And if it's a balanced design, which it was because we had 10 paper airplanes for each paper type, then the coefficients must sum to 0. So this is a contrast that we're going to be using in today's video. So we can see that there is the mean of the cardstock, and then we have a minus, mean of the printer paper, and mean of the lined paper. So this is the average of the other 2. And we can see here that our coefficient is positive 1. And then our coefficient is negative 0.5 and negative 0.5. And of course, 1 minus 0.5 minus 0.5 is 0. So we have met that conditions of a balanced design. So our null hypothesis, is going to be that the contrast is equal to 0. Well, the alternate hypothesis is that it's not equal to 0, because that would show us that the mean of the cardstock is actually different than this average over here. In order to test this contrast, we are going to be using JUMP. And so here is the data that we were looking at before. We're going to go up here to Analyze, and then we're going to go to Fit Model. And so our Y, which is our response variable, is the average distance traveled. And our construct model effects we're going to put in our explanatory variable, which is the paper type. We're going to run that. And so first it's important to see if the paper type actually affects the distance traveled at all. So to see that, we can go down and we can see the analysis of variance table, or the ANOVA table, and we can see that there is a significant p-value, which tells us that the paper type does have some sort of effect that's statistically significant on the distance traveled. So to test our contrast specifically, we need to go up here to Paper, and we're going to go to Least Squared Means Contrast. And so here, we're going to be putting in the coefficients of our contrast. So we can go back and look at our contrast. We can see that the coefficient of cardstock is actually a positive 1. So we're going to put a plus right there. And then the coefficient for printer and lined are both negative. So we're going to put a negative here and a negative here. And so JUMP automatically assumes that we have a balanced design, and so you can see here that this is a negative 0.5 and a negative 0.5 because it's automatically trying to make these sum out to 0. We're going to press Done, and we can see here that we do have a significant result at the 0.05 significance level. However, we don't actually know from this information if the cardstock or if the average of the lined and printer paper is more. So to do that, we can come back over here and go to Analyze, and we want to tabulate. So you put our paper type over here and our average up here, and then we can just do means to see which one is the greatest. So here we can see that the average distance traveled for cardstock is actually 206 inches, while lined and printer is only 177 and 173 inches. So this table then tells us which one is greater. So here we can see a summary of our important results that we got from JUMP. So we have a significant value here for our ANOVA table, which tells us the paper type. And here we have a significant value here for our contrast, which shows us that our contrast is indeed significant. And then our averages over here just tell us that cardstock is indeed greater than lined or printer paper as to the distance traveled. So this brings us to our conclusions. And so we can see that at the 0.05 significance level, that our results in fact are significant, and the cardstock paper is greater than in distance traveled compared to the lined or printer paper. And so we use random assignment in our study, and so we can claim the type of paper used caused the average distance traveled to change. So if we're trying to maximize the distance flown, then we can recommend that cardstock paper is used. Thank you so much for watching my video. Have a great day.